guys, so for this video we're determining reaction orders and the numerical value and units of the rate constant. So we have this equation here. Use the following data for the reaction. 4C2H3N plus O2 results in CO plus H2O plus 4NO. So for this kind of problem we're going to use the equation rate equals K concentration of A, power of X, concentration of B, to the power of Y. You can also have to the concentration of C, to the power of Z, and so on, but this one only has two columns, so we're just going to use A and B. So what I like to do for the first one, I try to find values that have the same numerical value, so that when you put them on top of each other, they cancel out. So for this one, I'll use equation 1 and 2. I'm just going to write it over here. And mind, this does not, these numbers, you don't have to multiply them into the equation. It's just a reference for you to know, oh, I'm using equation 1 and 2. So you're going to use this equation and use these values to write it out. So for the first one, it's 2.4 times 10 to the 9 equals K, which is an unknown value, concentration of A, to the power of X, also an unknown value, and then Y. So that's number 1. Then you'll go ahead and write the division sign, and then we'll write equation 2, so rate K, value of A, value of B, to the Y. So as we can see, we have these set up to divide each other. Now let's look. We can cancel some things out already. So you can cancel out K, you can cancel out these ones because they'll just make 1 as well as the X. So it leaves us with this. So then we can go ahead and calculate what that leaves us. So 2.4 times 10 to the 9 divided by 6 times 10 to the 8th leaves you with 3.5, around 3.5. And then when you divide these together, it gives you 2, the concentration of Y. So in order to get the concentration of Y down, you have to add logs in. So then you can do log 3.5. And then when you do log here, you can bring the Y down in front of it. Okay? And then all we have to do now is solve for Y. And Y equals 1.8, which you can round to 2. Cool. I know that's pretty involved, but we're not done yet. We have 2 more steps to do. So we found Y, so that we can plug into an equation here. But we still need to find K and X in order to find the order. So for this, next we can use 2 other equations. So like the first one, we were looking for 2 of the same values, but for Y, they don't have any values. So what you can do, since we already found Y, we can go ahead and use 2 of different equations to divide over each other, but X has to be different. So I'm going to use 2 and 3. Okay, so let's write 2 first with this equation in mind again. So rate equals K, concentration of A, to the X, and then concentration of B. Now I will put to the Y, but we already know Y, so I'm going to insert that already. 2. So there's equation 2, and then we'll go ahead and write equation 3 right under it. Okay. Concentration of A, and concentration of B. And again, we already know the value of Y, so let's plug that in. So now we're left with this unknown that we can solve for, and we can cancel out k because it'll equal 1. So then when we start solving for it, we get 2 equals, and you divide. Oh, right, yeah. 0.5 to the x. Then we divide this, you get 4. So again, we just have to solve for x, but let's move this over here. So divide by 4. And then again, to take the exponent down, you have to do the log. And you bring the x down in front of it. And divide by log. So once we divide by log, you can see x equals 1. So to find the order, you simply add the exponents together. So 2 plus 1 is 3. So this this whole experiment for this equation is third order. Now let's just finish up and solve for k. So for k, since you have x and y already, you can just pick any equation you want and plug it in. So I'm going to pick equation 1. Concentration of A. And remember, we know x. Concentration of B. And we know y. And then we can go ahead and solve. Oh, sorry. So this gives you 2.5 times 10 to the negative 5. And you multiply by that, and it gives you times 10 to the negative 11th. So divide by this, so we can get k by itself. This cancels into 1. So finally, we have k equals 2.5 times 10 to the 19th power. There we have it. This equation is solved.